that goes from the south leg of the arch to the north leg of the arch, that path is symmetric about like that central axis. Like if you went from the south leg of the arch to the middle of the path, and then you went from the middle of the path to the north leg of the arch, the shape of the path you take on both sides are symmetric to each other. And so our little trick of finding the entire arc length and then setting up that linear relationship between arc length and T, and then rewriting, it was the last thing we did on the day that we worked on there was that day that we worked on the arch bike path problem. It was the last thing we did where I don't remember off the top of my head exactly what the arc length was, but let's say the entire arc length was 15,000 feet, and we went from 0 to 12, so then if you took 15,000 divided by 12 times t, that would equal s. This is what we did. So if I plug 0 in, my arc length is 0, because I haven't started on the path yet. If I plug 6 in, I've gone half of the distance. If I plug 12 in, I've gone the whole distance. So we then took 12 times s, or s was the length you went on the path, equals t, and we replaced all the t's in the formula with this, and then we were able to use that to plug in, you know, a mile and see where we were on the path after we went a mile. You know, if I plug 5,280 feet in, that's a mile. So we did that with that problem, and that worked because the path is symmetric on both sides. But in general, you can't just assume this linearity between t and your arc length. And I kind of discovered that by working with the problem that you have on your homework. Your book talks about this idea of reparameterizing, and the examples that they give, the arc length is linear itself, and so it's real easy to write relationships like this, and those are the examples that they give. But when you get a more complicated function, unless r prime is constant, then the t does affect what length of path you've taken. And so, for example, with the problem that you're supposed to do for your homework, if you find the arc length from 0 to 20, because that's the full length of t, you get a certain length. But if you then find the arc length from 0 to 10, where 10 is half of what your t's are, you don't get half of the arc length. You only get close to a third of it. And it's because, as you can see at the beginning of the path is straighter, and then the path gets wavier toward the end. So according to t, you have to cover more t to move distances towards the end of it. So we cannot make this assumption. And so you still could answer the question, find where a person would be on the path if he or she walked a quarter mile or a half mile. Okay, you can still do that, but it takes a little ingenuity of either working with your calculator or working with Mathematica. I'm trying to, you know what, I think the simplest thing would be to just work with the calculator. The only problem is that if your batteries are kind of low, it takes the calculator a little while to think, whereas Mathematica will spit it out a little bit more quickly. But why don't we work with calculators, since everybody has those and we don't necessarily have to worry about Mathematica.